everyone, this is the second video for section 5.5 in your intermediate algebra book. We're going to start with example 8 on page 200. Alright, so example 8, the directions say solve, so we're still solving radical equations. The square root of 2x plus 9 is equal to the square root of x plus 7. And of course, when you're solving, the whole goal is to isolate x. So when you're solving a radical equation, you need to isolate the radical. I think this is the first one we've done that actually has two radicals in it. Yes. When you have two radicals, just make sure at least one of them is isolated, and then you can use the exponent to get rid of it. Now, we're fortunate here, they're actually both isolated, so we can get rid of this radical by using the exponent. And don't forget, you're using the exponent that matches the index. So in this case, it's an exponent of 2. And that exponent is the opposite operation of the radical, so they cancel each other off. And then you end up with 2x plus 9 equals x plus 7. At this point, at this level, you should know next what to do. You're left here with just a basic linear equation. You're going to put all the x's to the same side, all the constants on the other side using opposite operations. So subtract this x. We have x plus 9 equals 7. Subtract the 9. We have x equals -2. Now don't forget, with radical equations, it's imperative that you check your work. So over here on this side, we're going to check, starting with the original equation, the square root of 2x plus 9 is equal to the square root of x plus 7. And we're going to take our solution, x equals -2, and we're going to substitute it both sides for x here, and then we're going to simplify each side down. So that's going to turn out to say the square root of 2 times -2 plus 9 equal to the square root of -2 plus 7. There we go. Now we're just going to simplify, and again, when you're checking, you do not move things around. You're not going to have to get rid of this radical. All you do is simplify down to see if the two sides are equal. So we're going to multiply, and then we're going to add here. 2 times -2 is -4. -4 plus 9 is 5, so I have a square root of 5 here. When I add on the right side, -2 plus 7 is also 5. So these two sides are equal. You don't even have to get rid of the radical. You don't have to simplify this any further. This checks out because these two sides are equal, so you know that you have a good solution here. All right, we're going to work on example 10, page 201. It says the fifth root of 5x minus 17 equals the fifth root of 3x minus 7. Same idea here. Both the radicals are isolated, so we're going to use exponent 5. And that cancels the radical for us. We left with 5x minus 17 equals 3x minus 7. We're going to solve this by putting the x's to the same side. So -3x, that gives us 2x minus 17 equals -7. We're going to add 17. So 2x equals 10, and then divide by 2. So x equals 5. Of course, we're going to check over here on the right. Starting with our original equation, the fifth root of 5x minus 17 equals the fifth root of 3x minus 7. We're going to take our solution, x equals 5. We're going to substitute it in there. So 5 times 5 minus 17, the fifth root, equals the fifth root of 3 times 5 minus 7. And we're just going to simplify this down. 5 times 5 is 25. 25 minus 17 is 8. So this comes out to be the fifth root of 8. So let's see what the other side comes out to be. 3 times 5 is 15. 15 minus 7, not 17. Got to, there we go. 15 minus 7 is 8. So this checks out, and our solution is x equals 5. Okay, we're starting on page 202. This is example 11. It says the square root of x plus 4, and then there's a plus 2 that's not under the root, equals x. We're solving here, so the goal is to isolate x. Before you can isolate x, you have to isolate the radical so that you can get rid of it. To isolate this radical, I have to get rid of this plus 2. So anything that's not in your radical, you get rid of first. So let's subtract 2. And we get the square root of x plus 4 equals, this is interesting over here because these are not like terms, so we're going to have x minus 2. All right, to get rid of this radical, we're going to have to square this, which means we're going to have to also square this side. So this is fine. This turns out to be x plus 4 because the exponent and the radical cancel each other, but there is no radical on this side to cancel with this exponent. So this, you're going to have to actually write it out and do the double distribute. So this is going to be x minus 2 times x minus 2, which comes out to be x squared minus 4x plus 4. So this is not a linear equation because of this x squared here. We're going to cover solving quadratic equations, which is what this is, in chapter 6, but I'll just go through the steps right now. To solve a quadratic equation, the fastest way is by factoring, but to factor, you have to have everything all to the same side and equal 0 over here. So we're going to move all these two terms over here, combine them with these terms over here, and then we're going to factor. So what are we going to get? We're just going to subtract x, and we're going to subtract 4. And that's going to give us the 0 over here that we want. Then we have x squared minus 5x. Now to solve this, we're going to need to factor. So we'll have x, there's just a GCF here, times x minus 5. So those are the factors here. This is based on the zero product property, where if two things multiply together to make 0, it follows that one of them has to equal 0. So your two solutions here are going to be about this zero product property, and they're going to say x equals 0 from this GCF here, and also x minus 5 equals 0 from this binomial factor here. This one's already solved, so this is one of your solutions, x equals 0. This one, we're going to isolate x, so we're going to have x equals 5. So these are your two solutions for this example, x equals 0 and x equals 5. Okay, moving on to example 12. Still on page 202. Example 12 says the square root of x minus 2 equals 1 plus the square root of x minus 7. And this is a case where we have two radicals One of them is isolated, but the other one is not. There is really no way to get this one isolated and keep this one isolated at the same time. So we're going to go ahead and get rid of this radical first by squaring. Use the exponent that's the same as the index, but that means we have to square this side too. So this one turns into x minus 2 over here on the left, but over here on the right, you have a binomial. So what you're going to have to do is you're going to have to write that out as 1 plus square root of x minus 7 times 1 plus square root of x minus 7, and use double distribute or FOIL on that. When you FOIL all that, you end up with 1 plus 2 square root of x minus 7 plus x minus 7. If you're in my class and you're watching this video, we can talk about this when we get to class. It's just basically 1 times 1, 1 times square root of x minus 7, and then another square root of x minus 7 times 1, and that makes this 2 here. 2 square root of x minus 7, because there's 1 from here and 1 from here. And then at the end, when you multiply these two terms together, you're squaring the square root of x minus 7. So by multiplying them together, the radical disappears, and you just end up with x minus 7. Now, we need to isolate this so that we can get rid of it. So we're going to bring the rest of these terms over to this side. So I don't know if we can do it all in one. Let's see. We need to subtract 1. We need to subtract x. We need to add 7. So if we do all that over here, subtract 1, add 7, subtract x. Those x's cancel. This turns into 4. Negative 2, negative 1 make negative 3, plus 7 is negative 4. And this is going to be just this left because we got rid of all these other things. So 2 square root of x minus 7. Now we can isolate this radical here by dividing off this 2. Since this operation is multiply, we divide to get rid of it. So we have 2 equals the square root of x minus 7. And now we can use another exponent to get rid of that radical. So we have 4 equals x minus 7. One more step so that we can isolate x will be add 7. We get x equals 11. All right, we're up to example 13 now on page 203. Example 13 says solve the square root of x plus 5 plus 9 equals 12. And of course, again, the whole goal of solve is to isolate this x. So we need to isolate this radical so we can get rid of it. We're going to subtract 9. Just isolate the radical. So we have the square root of x plus 5 equals 3. And then we're going to square so we can get rid of the radical. And remember, use the exponent that matches the index on the radical. So this becomes x plus 5 equals 9. Subtract 5 to isolate that x. We get x equals 4. We could go back to checking these, since this was a few steps here. Write your original equation, square root of x plus 5 plus 9 equals 12. Substitute your solution in there for x. And then simplify. So this will be square root of 9, which is 3. 3 plus 9 is 12. on the left, also 12 on the right. This checks out, so we have a good solution here. Okay, we're up to example 14 on page 203, which is a word problem, so I'm going to read it and I'll write the important data down for us. The formula for the radius of a cylinder is given by the square root of V over pi h equals R. The height of a certain cylinder is 10 centimeters and the radius is 5 centimeters. Use the given formula to find the volume. So I need to be solving for volume, and it says use 3.1416 for pi. So I need to be solving for volume, which means I'm going to isolate this V, but I'm going to take these and plug them in where they belong, and then simplify and isolate that V. So let's start with that. I don't know what V is, but I do know that pi is 3.1416, and I know that height is 10, and I know that radius is 5. Now I should simplify as much as I can. So I'm going to multiply this pi times 10 in the denominator of this fraction here will be 31.416. Now I have my radical isolated here. To solve for this V, I need to get rid of this radical. You do that by using an exponent. The exponent that matches the index here is a 2. Same thing to both sides. So the radical will get canceled off. So I have V over 31.416 equals 5 squared, which is 25. Now to isolate this V, I'm going to need to get this denominator off of here. This is divide, so to undo it, we multiply. So I'm going to multiply both sides by this 31.416. And that will make it cancel here. So I've isolated my V. And of course, you can use a calculator for this. I think that comes out to be 785.4, and since it's volume, the units were centimeters, this will be cubic centimeters or centimeters cubed. Okay, we're up to example 15 on page 204. Another word problem, so I'm going to read the word problem and write down the important information. The formula for the radius of a sphere is given by the cubed root of 3v over 4 pi equals r. The radius of a certain sphere is 6 centimeters. Use the given formula to find the volume of the sphere. And again, for pi, we're going to use 3.1416. So this is the same type of question. It's just a cubed root instead of a square root. We're going to take our information, we're going to put it into the formula, and then we're going to isolate the V. The directions say find the volume. So we're going to isolate the V. All right. So 3v, I don't know anything about that v. I do know that pi is 3.1416, and I know that r is 6. I'm not going to multiply any of this stuff out until the end. I'm just going to continue to move on and isolate my v, and then I can put it all in the calculator at one time. I'm going to use a cube here because it's a cubed root. That's going to give me 3v over 4 times 3.1416 equals 6 cubed is 216. Still trying to isolate v. I'm now going to multiply times this, both sides. It will cancel off of this side. I believe it's 12.5664. And that cancels. Multiply it times that side, and that gives us 3v equals whatever this is. I'm actually just going to write these numbers out. Trying to isolate v, I'm now going to divide by 3. Now, if you did all this without the calculator up to this point, it's perfectly fine because you can put all of this in your calculator at one time. You have no rounding errors. You just round it at the end based on whatever the directions tell you. This comes out to be 904.8, and again, this is volume, so it's centimeters cubed.